I saw to me, I put one down here. Right, sorry, I'm just having a chin wag. Is everyone okay? Hi, so thanks for coming along to listen to us this afternoon. My name's Aimee Pinnington. I'm a lecturer at the moment at Salford University, but previously worked at Salford University. So the panel of members we've got here, and perhaps if we take turns to introduce ourselves after when we've all got the mics so people can hear you. We've got 3 of our students from Salford University and Dr. Sarah Namvar on the end, who's a lecturer at Salford University. So even though I've left that university now, we wanted to come and talk to you today about making the most of the student experience and some of the brilliant projects that they've got on the go at Salford University, and hopefully that inspires you to either take things off into your own universities or your own practice. So a little bit of background. I worked as a biomedical scientist in haematology and blood transfusion at Royal Stoke University Hospital before moving off into a bit of a split between working in the lab and working in academia. And that's how a lot of these projects first started to come about, with the links with the IBMS. So the IBMS very kindly funded some of the projects that I will talk to you about afterwards with outreach, and we've had a lot of guest speakers coming in, growing some of the career groups and the magazine, which Nelly will be talking to you about, I think, shortly. So I think without further ado, it's probably best to hand over to you guys, and I think because we're doing this as a panel, if anyone's got any questions as we're going along, maybe just give us a wave and we can take them in turn, or Sherry, if you've got questions as we go. We're quite happy to all be interrupted and ask as we go along, so that this can be a useful talk for you guys as well. Yeah. Hi everyone, can you hear me okay? Yeah. So I'm Sarah Namvar. I'm one of the programme leads at the University of Salford and also the head of student experience for the department. So as our students will showcase shortly, we've been really good, I think, as a department in supporting students to drive their own independent projects that ultimately lead to greater employability. So one of the things that you're probably very likely aware of is that it's very, very competitive when you go out there. And even before you go out there, securing placements is incredibly difficult. So how do you make yourself stand out from the crowd and make your CV not end up in the bin? So I don't want to talk too much about the projects, really. I'll maybe talk about one of the old ones that is still at Brimming for the 4th year this year, Salford Passion Flash. So this was a project that was actually co-created with students around 4 years ago. And it's essentially students given a TED-style public speaking competition. So the academic team worked collaboratively with students to put in for some funding, and students give a really nice flash talk in out at Salford Media City. And that happens each year. One of the other things that we do as an academic team, and we work very collaboratively with our students to deliver things, are careers events, mentorship for careers both within the biomedical sciences profession and other things such as graduate entry medicine. There are lots of other projects that you can see on here. I've probably said enough for now, so I want to hand over to our students who actually do the bulk of the work. They really help, and this is one thing I'll just say. In addition to doing all of this work that you can see on here, and they're very high impact and they bring in lots of other students, they're also instrumental in doing a lot of the departmental work. So induction week, they really do genuinely help us plan that. Trips, outreach, all sorts of things that help the department our students are driving. So I would encourage all of you, both at the University of Salford and otherwise, to do the same, because that's what will make you stand out. That's enough from me. Maybe I'll hand over to Abby and Nadia.
So I'm Abby. I'm in my last year at Salford studying human biology and infectious diseases, and I worked with Nadia on our magazine from the Biomed Society called the Bioscientist magazine.
Hi everyone, I'm Nadia. I'm also at Salford working with Abby on the Bioscientist magazine. I led the Biomedicine Society throughout the pandemic over last year, and even though it was a really tough time for everyone, being away from what we thought was normal, we managed to put together some really good projects that have lasted and sort of we now adapting them, which now started off completely remote. We're now in the process of adapting them to in-person and sort of face-to-face activities, which I'm going to talk about in the magazine in a minute, which was actually one of the biggest projects that we've had.
Hi everyone, my name is Olivia and I'm a second year human biology and infectious diseases student, and I'm also currently the treasurer of the Salford Biomedicine Society. One of the projects that I led in the first week of taking up my role was the IBMS outreach project, and this was, you can see at the far corner over there, this was a very last minute decision that we took on in the final week when we saw that the IBMS was providing us funding for IBMS Day. We read the guidelines and it did say that we had all the way up till September to try and do something with the funding they were providing us. So what we did was we got together, and with Aimee and Sarah and another co-colleague of mine as well, we got together and we put some plans together that what do we really want to do. And we really wanted that, when I was especially a high school student and a college student, I found that I didn't really know much about biomedical science. So we really wanted to get the word out there, let students know what biomedical science really is, because there's just this thing that students just don't know much about it. So what we did is we did the Biomedical Science Day outreach project, and we sent out around 500 plus outreach packs around Greater Manchester, and I think it was so successful because we had teachers come back to us and they told us how students that didn't have much ability, or they had special needs, they found it very interesting. And we provided a craft project as well, which was funded by the IBMS funding, and it was just something that was really nice to do and to get the word of biomedical science out there as well. Some other things that we also do is social events, and social events is really important as part of your student life. And this is something that takes you away from biomedical science and away from your courses, and it allows you to interact with students. And it gives opportunity for other students to ask questions to us as to how are we doing this, and giving them the opportunity to lead their roles further in the year.
So if we talk a bit about the magazine, and before I start, a common theme throughout all the projects that we put together throughout the pandemic are basically to do with creating the opportunities for ourselves where there wasn't any. We realised that because of the pandemic, like I said, we were distanced from everyone. We needed to put together a project that was collaborative, that was still productive, and that was conducive to sort of the online world that we were sort of thrown into. And so we decided to put together a magazine as a way of coming together, as a way of bringing lots of different students together, from sort of students that have a real diversity in their skills and in their backgrounds, and using all that diversity and skills to make something that is, that reflects sort of the strengths of our student community. We really modelled it on the IBMS magazine, The Biomedical Scientist, but of course we started off at quite a small
Little team.
Quite a small team, and that has grown. It was quite a small publication, which then grew. It's now twice. We're on our third issue now, and it's going to be coming out hopefully this month or next month. And it's grown like twice the size.
Yeah.
If you want to talk about perhaps some of the pieces, the topics that we cover.
I joined the team in the second issue as an author and wrote an article about whether there was a biological link between autism and suicide. So focusing more on the neurological aspect of it rather than the psychological aspect, and finding about how parts of the brain in people with autism are more likely to be depressed because of serotonin levels not being as high as someone who isn't autistic. And that kind of thing isn't what I generally look into at university. I'm more interested in microbiology and virology, so getting a chance to write an article and do more research in more of a neurological background was really exciting, because it was something that was fun and it wasn't going to be graded. I wasn't writing it because I had to, I was writing it because I was genuinely interested and wanted to. And then in this issue I've joined Nadia on the more the production team of the magazine.
Editorial team.
Yeah.
Yeah. I think that's a really good point that you raised about people writing about things that they're genuinely interested in. I think sometimes our degree programs can be quite technical, and they can be quite structured in a way that makes you feel as though you don't have a lot of choice in the things that you can go away and read about. Whereas even though, so we're giving students the opportunity to go and read and research and collate research in a topic that really interests them, I think is a really good way of encouraging sort of wider reading and widening that scope of the sort of technologies that are available. I think there was one student who wrote about something, who broke down a scene from medical drama.
Yes,
and
that's in the newest issue, isn't it?
Yeah, it's coming soon. So talking about how realistic it is, or how and how that would really work in a real healthcare setting. So that's really interesting.
I think, just to add on to what Nadia said, it doesn't have to be just a writing perspective. So like Sarah mentioned, Passion Flash, that is one of our TED style talk on video. I think it's more of a face-to-face platform. We did it via videos last year, but this year we're keeping it face-to-face. So the auditions were online, so they sent over the videos of Sarah, and then we're going to hold the finales in Media City, like she said. And I think some students, they may not like the writing aspect, so having an aspect where they can talk to people like this, it might suit other students better. So I think it's a really nice opportunity, especially universities, to introduce something like Passion Flash. Also, just adding on to that, something else that I completely forgot to mention was our Bio Art Club. So we have a club that we run, and our society, what our society is we don't really focus. We do focus on biomedicine, however, we focus on other skills that students can pick up on. So we have the book club, where students get together at least once a month and they read a book that they have chosen. So they read the book in their own time, and then we all come together and discuss what we learned from that book. And another thing is the Bio Art Club, and we set a competition around October, November time, and we give them a theme. This year's theme was perceptions of pain. So what do you think about when you think about pain? Everyone has a different perspective on a certain word. So we've had around 27 entries, I think.
I think so. We got it down to about 20.
Yeah, so we had around 27 to 30 entries, and they've all been shortlisted, and we're going to hold an art exhibition next week, hopefully. And this is just a really nice way for students that have other skills like art, and they have I'm not sure.
Creative.
Yeah, creative.
So the idea behind the art as well is that it will feed into entrepreneurship, hopefully, eventually. We're seeking funding for that at the moment. So if anybody would like to get involved, I'm never embarrassed to plug a project. So essentially what we're hoping to do, eventually students will get the opportunity to print their own art onto bags, t-shirts, that sort of thing. It might be that they set up their own company. That's the idea.
So that's behind Art Club. And we also do have our newsletter. And something that's really important is that we decided to consider the well-being of our society students, and we decided to introduce some sports sessions. So we fund the sports sessions. So we apply for a grant from Students' Union, which I'm sure majority of the universities do have. So we apply for a grant for them to fund some sports sessions. So we hold badminton every week on a Monday in a specific allocated time, where we feel that all the students are free, or majority of the students are free. And I think this really helps in with the well-being of students. And some students may realise that they have skills in certain sports that they've never actually played. So I think that's a really nice idea as well.
I think what comes across in everything that the students have talked to you about today, all of these projects that we could spend 20 minutes talking about each individual project, is that these have been student-led initiatives, and you've got either practicing biomedical scientists like myself who've got involvement with the IBMS, or you've got brilliant lecturers like Sarah. All of you will have people like us in your own university, and you can take your degree to another level and really help yourself to stand out, because all of you guys in here are going to leave university with a degree, but what makes you different from the person you sat next to, and what makes these three different from you guys, why aren't you guys doing things like this and making yourself to a point where you're going to be the most employable, you're going to be able to get the most opportunities out of your degree, and it's so much more than just the assessments and what mark did you get here and what enjoyment did you get out of it. Hopefully it comes across that these three, as well as all the other brilliant students we've been involved with, really enjoy the work that they're doing here. And yeah, just thanks again to the IBMS for sort of funding a lot of the projects that we've talked about, and the extra opportunities with the podcast and things like that we've all been involved in.
So I've got a question. If any of the students here are feeling really inspired about your magazine, is this freely available to look at, or is it internal?
It's freely available to look at.
Okay,
So
where would we start in looking that up?
So we go through a platform called Issue at the moment.
Mhm.
We are working on getting, we're working with our library department to get it more accessible so you could find it through Google Scholar. But right now, if you go to our Twitter page, which is, can you remember what
Salford
it is?
Salford
Biostock.
Yeah.
We always plug it in there, the link to access all of our available issues. They're all online.
Just spell that out.
SALFORDBIOSOC.
So Salford Bio SOC
Yeah.
on Twitter
And on Instagram.
and on Instagram.
All the platforms.
So that's one version of the magazine, which is sort of the print version. It's got like clickable pages, but virtual. We also have an online webpage, which is powered through WordPress, where we publish individual articles. So that's sort of a running thing as well. But again, the link to that will be on the Twitter page. So everything's there.
Lovely. Round of applause for our panel. Has anybody got any questions? No? Okay. Our next two speakers, Martin and Rob, who wants to go first? Or you come on the
Depends
pair?
which one comes up first.
Do like a drum roll or?
Let's see. How do the slides? Oh, it's me first. Well, look. Is it? Oh, is that you, Martin?
It's me.
Yes, please do. Who are you?
Okay. Right, my name's Dr. Martin Khechara. I'm from the University of Wolverhampton. I know I haven't got very long, and so I'm going to smash through this nice and quick. Now then, my job is I'm a senior lecturer in microbiology, and I'm also an associate professor for engagement in STEM. So my job is talking, right? Let's have some noise from the Wolverhampton crew that are in here. Fantastic. See, that's what we want. Some audience participation. That's great. So, we've heard a lot today. You've sat through loads of people talking, and that's really good, right? And I hope you've learnt loads. But they've told you that certain things are important, right? That's what they've done. They've said, be involved, go out there, do things, make yourself better than other people. And I can't stress that enough, right? But I'm going to prove to you that it's important for one other thing. And I'm going to ask you a fundamental question, right? What are you? I am me. What are you? What are you?
The soul.
A person, a human. I'm a soul. What are you?
I'm human.
Human, yes, we're humans. We're all humans, but students. Some of us are students. But perhaps I should rephrase the question. Who are you? Okay. So who are you? Who are you?
Fighter.
A fighter. Oh, come on. So, who are you? I know who you are. Right. Who are you?
I'm a seeker.
Okay, there you go, right? So, a seeker, that's what he says. A seeker of knowledge, and that's fantastic, right? But, all of these things are really important, alright? Because of one simple thing. It's because you need an identity as a professional. I noticed nobody said, I am a biomedical scientist.
Nobody asked me.
Right, there you go. Right? As students, do you draw a link with you being a person learning to be a biomedical scientist and being a biomedical scientist? The question often is no. Alright? Because yes, you're learning the trade of biomedical science, of course you are. But you need to be able to develop that identity. We might call it a practitioner identity or a professional identity. They're the qualities that build into you associating yourself with your discipline as a biomedical scientist. All right? And only then, once that lightning goes off in your head and that light bulb goes, bong, I actually am a biomedical scientist, will you be desirable, I think, in my head. Because you become that person then, right? You stop being a student. It's like a child growing up and becoming an adult. You know, I know loads of people say you never learn to drive until you actually start driving, right? But that's rubbish, right? Why can't you develop that practitioner identity now, right? And associate yourself with your discipline or the world of biomedical science? Another question for you. When you say to people, I'm a biomedical scientist, do they know what you mean?
No.
No, the answer is no. Right? I've done 5 years worth of research on this, and nobody knows what we do. All right? Other students, actually, that was really interesting, because even nursing students don't know what you do. Do they? No. Right? And that needs to change. All right? And we've heard this term, right? Public engagement. All right? Public engagement, of course, going out and talking to people. I'm engaging you now. I'm getting some nice bits of feedback from you. It's a two-way communication. I'm learning about some of the people in the audience. That's real public engagement happening right there. All right? For you to be able to go out and talk to audiences, talk to the public, do sort of sessions with your university, even if it is on an open day, allows you to start developing the communication qualities that you need as a biomedical scientist. But what it also does is puts the shoe on the other foot for a change. You become the expert talking to the novice. And then you will develop that identity that you need to be a biomedical scientist. All right? Until you suddenly realise, hang on a minute, I actually know what I'm talking about. Then you will be rocking and rolling. You also could do a bit of outreach. Right? When you talk about outreach, all right, that's not just you going into schools or working at science festivals or volunteering for things. What that is really creating awareness and enjoyment and understanding in an audience all about what you do as a biomedical scientist. And of course, this is all building your skills, because some of the tacit skills we can't teach you at university. All right, I can't teach you the real communication skills that you need to negotiate with somebody. I can't give you the confidence and resilience you need, trust me, to work in a laboratory, right? Mm-hmm. And so you can only do that by putting yourself in front of another person like this and talking to them about your speciality. And then we can create the awareness we need about our subject area. And then maybe then, when you say to somebody, I'm a biomedical scientist, they go, oh, that's one of them scientists that works for the NHS in the laboratory. You do a fantastic job and you deserve a pay rise. All right? So hopefully that will help. But it's all about developing this persona as a biomedical scientist. All right? Breaking down that barrier, becoming not a student. Those of you who might have been on placement will have that. You will know that you are a biomedical scientist, but it's more difficult for other people who don't go out on placement. So, that identity you can build for engagement with the public and with your university, just like we've heard our students saying before, and getting involved in outreach, no matter how small it is, to be that expert. So do volunteer and do get involved, because it's up to you. Right, this profession is nothing without the people who are going to be the biomedical scientists of tomorrow. All right, so you are taking on this mantle now. So, if you want to know more, or you want to know how you can get involved in public engagement or anything like that, then please just add me up and get in touch. Thanks everyone. Cheers.
Thank you. Has anyone got any questions for Martin? Tough crowd? Yeah. Yeah?
That's all right.
Okay, I'd like to welcome Rob then.
Hello everyone.
We'll put the mic up.
Sorry, I'm quite tall. I can't believe I got to follow Martin. It seems really unfair. He set the bar a bit high because this is not going to be as animated as his, but hopefully there'll be some interesting stuff in there for you. So I'm going to talk about careers and opportunities in science and healthcare journalism and give you a few writing tips and job opportunities, stuff like that. I'm the editor of the IBMS magazine, The Biomedical Scientist. So a bit about my background and where I came from, because I haven't got a scientific background like you lot. I've got 2 GCSE sciences, and they were both C, but didn't work very hard. So then after that, I did a degree in English, and then a master's, and then some journalism qualifications. I went on to work on some newspapers down on the south coast, weekly newspapers, and then daily newspapers. Ran a newspaper office for a while. Then moved up to London, where I was a freelance music journalist and film critic and editing some kind of cultural magazines and stuff. But I don't think I was very good at it because I got very bored of the type of music and stuff I had to cover. And then healthcare journalism came along. And I started working for kind of a load of different organisations, the Royal College of Midwives, the Institute of Physics and Medicine and Engineering, but mainly the IBMS. And yeah, there are lots of, if you're interested in writing, there are lots of different ways into it. You can write for newspapers, magazines, academic journals, online. And there are lots of different skill sets you need for all of them. So if you want to write for a newspaper, you need to be kind of quite hard-nosed and good at doing things quickly. You need certain qualifications, such as an NCTJ fast-track course to get you qualified as a journalist. Magazines, similar thing, but you don't need to be quite as qualified. You can pitch to write stuff for a magazine without any formal training or qualifications. And academic journals, which might be of interest to you, because you're all going to be specialists in your subjects. And then what you can do, if you go further on into academia, you can start pitching, doing research, and it's a really good thing to do. The different types of jobs you'll come across are editor, sub-editor, reporters. If you're a reporter, you're the one out on the ground getting all the stories. Sub-editors have to have kind of a real minute attention to detail, be really good at spotting clauses and be dead on with grammar and stuff like that. So real perfectionists, which I'm not, which is why I've never been a sub-editor. Then you've got the editor, which is kind of the person who looks after the whole big picture. So the kind of concepts behind the article, how the whole magazine fits together and flows, commissioning articles, stuff like that. There are loads of other opportunities if you are interested in communication, but you don't want to be a journalist per se. Then press officer, copywriter, communications, all trusts will have big communication teams, or pharma companies. Basically any body involved in medicine in some way will have some kind of communications team, press officers, media officers, copywriters, all that type of stuff. So if you're interested in words, but you don't want to do reporting, there are still lots of different avenues you can go down, places that you can go. Okay, so a quick thing, these are tips that you can extrapolate into the other work that you're doing as well. So there's something called the inverse triangle, which sounds really boring and complex, but it's just basically a big triangle like this, and you use it for news stories. And you think the most important thing goes first, then the least important, then the next important thing, then the third most important thing. And with news stories, you just carry on until you run out of anything interesting to say. The analogy that people always use, or that I was certainly told when I was training, was think of it like you're in the pub with someone, and if you want to tell them about something, you know, you naturally tell them the most important thing first. It's like, God, the Ukraine has just been invaded by Russia. And then you tell them the second most important thing, you know, the tanks going in, the people who are dying. And then you just carry on, and it gets less important and less important until you run out of anything of interest, and that's the end of your news story. Features, which this is something that might come in handy for you when you're writing essays and stuff like that, is you think you're always trying to tell a story. So you want to start, a middle, and an end, and you kind of progress through those. So if you think, say, think of it as a kind of timeline, and you might, if you're working on a project, you might think, what's the motivation for doing the project, why the project needs to exist, and then you go to the next stage, how you did the project, and then the next stage, what the results and outcomes were, And then the next stage, which is the future, any learnings who come out and tips for other people who are doing something similar. The other type of thing you'll see a lot of is the rise of mobile phone news and clickbait. So do many people read the news on their phones these days? Yeah? Well, I'm sure you'll come across these stories. I saw one the other day which was Kate has a charming nickname for Prince Charles. Did you see that? Yeah. I clicked on it, I had to scroll. And at the end of the story, it's Grandpa, which is such a laugh. It's not a nickname, it's just a term. Anyway, yeah, that's the type of writing you do not want to do, because that's purely monetized content, where people have paid for adverts on there, and the point of the article isn't to communicate stuff to you, it's to get you on a page where adverts are. So if you're ever doing any writing, don't use that as any kind of template, just ignore that, because it is a load of rubbish. There are lots of different ways you can get into writing, from work experience, which is a lot harder now in in COVID times, where previously we would have people who come into the office with me, they would sit next to me, I'd teach them how to write news stories, I'd give them press releases to write, and then I'd help explain how and why they'd done things well and what could be improved. It's a lot harder now to get work experience, but I know people are still doing it. We're still doing it occasionally at Redactive, the company I work for, who produces the magazines for the IBMS, and I know that the IBMS have had some work experience, people can get involved with their comms team. So that's one possibility. Pitching stories. If there's something you want to write about, then you should write about it. When you're telling someone, or when you go into an editor, or whoever it is, to say you want to write this story, there are a few things you need to remember. The first is to sum up the story in a single sentence. So say what it is, and then say why you're well placed to write about it. Blogging, podcasting, creating really good quality student magazines, such as we've just seen, they're all really good ways into it. And then finally, if you ever decide to pitch to me and my magazine, The Biomedical Scientist, there are a good few reasons to do it. Satisfaction. Writing's a really enjoyable thing. It can be quite cathartic, and it's really good to take what you've learned, get it down on paper, and share that learning with other people. CPD, it's a really important thing, and it's something that you need to do. Reflection, good way of looking back, and developing the profession. Martin talked a lot about how you were the scientist of the future, so you want to be taking the work you're doing, getting it published, and showcasing what you're doing. And that's it. If you want to talk to me at all, you can always drop me an email, or just call me now, or if anyone's got any questions, I'd be happy to answer them.
Any questions for Rob?
No?
I'd just like to add, I actually managed to publish my dissertation in the Biomedical Scientist years ago, and that really lifted my name. So I did my dissertation on a particular type of resistant gut bacteria, how we detected it in the laboratory setting. I looked at a variety of different methods. I trialled some different agar, some different biochemical tests. I looked at statistical analysis. I wrote it all up. I pitched it to Rob. Rob was like, yeah, I'm having that. And then it's about getting your name out there. And then I suddenly had different people approach me and, oh, we need to do that in our lab. Can we have a little chat? The particular agar that I used was new and up and coming, so there wasn't a lot of data out there. So I am going to plug networking, but it is about that as well. The Salford Uni students that are doing their magazine, maybe that's something that Rob would like. It's all those extra little satellites of skills that are on top of your degree, and yes, it's in your own time, but some of it like your dissertation, you're already doing that, or you've already done that. All you need to do is just chop it down into however many words that Rob's got to fill a page, fill a couple of pages. But I really would recommend that in terms of getting your name out there and networking.
Definitely, yeah. Quite a few of your lecturers and a good few people in this room have written for the magazine. We've got Martin on the podcast as well, if anyone wants to listen to a really good podcast. The IBMS pod, which we do every month. A main interview with a scientist, and then Martin normally does our lab life, which is more irreverent, punchy section at the end. So it's all good, and it can all be used for CPD and picking up some interesting stuff about the profession. And especially when you're at a young kind of formative age and you're studying and you're not sure exactly what path you're going to take, we're covering all the different specialisms, and it's interesting to hear from kind of professional people with years of experience about how and why they do their jobs, why they like it. So that's a really good resource if anyone's keen on podcasts.
Lovely. Thank you, Rob. Round of applause for Rob. So I guess I just really want to close and say thank you so much for giving up your whole day. It's been insane. It's been so fast-paced, and there's been so much information that I challenge you not to fall asleep on the train home or the coach. Go away, have a think, try and make some sense of the notes that you've made. You can do a bit of CPD, so you can reflect on what you got out of this, and maybe you think, actually I've got another question that I want to ask. I'm going to plug IBMS chat again, but that is a really good way of getting in touch with pretty much anyone in the IBMS. So I can put you in touch with somebody else, you can look at the past tweets that we've got there, have a think about what you do, what inspires you, what your next step is. So really, thank you. I'm going to be around for a bit. Rob, Martin, the comms team might be, so come talk to us. If not, safe journey home, and thanks again for coming.
We also understand that there's always a gap in the system. You graduate or you're about graduating and you don't have the full information on what's the next level to go. So Biometric Level Prep answers all your questions, literally all your questions. So we offer interview, so all specialties. So if you see that from band 8 to band 4 to band 8, for all specialty interview questions, they're all there with me. Right. So if you can see, so from either each band level on all NHS specialties, so either your hematology, microbiology, transfusion, we do have interview preparation for you. For instance, if you are from microbiology and you're looking for a band 4 position for microbiology, you could see there could be a question of what's the basic principle of spectrophotometry. You do have an answer for that. Describe the process of dealing with analyzer flags. You do have an answers for that also for your preparations. And that flows through all the IBMS approved departments there. So for instance, if you're looking at blood transfusion also, the section of blood transfusion for band 5, you have 109 questions and answers for you. So you'd say, how did you use communication to make possible influence in situations? You have a well-detailed answers for you for your interviews also. So biomed interview prep is just beyond the interviews questions. We do have a practice test, biomedical AI coach, visual laboratory, and portfolio assistant. So all these resources help to give you an opportunity to get your first interview and also pass your interview at a good rate. So if we go to virtual laboratory, you could see that we do have virtual laboratory for all the IBMS approved specialties over there. For instance, if we go to say blood transfusion science, you could see that there's an idea of the virtual laboratory, and there are a lot of training options there for you also. So you could see knowledge about blood group typing station, you could see component preparation. So you literally have everything you need. You literally have more than you need to pass your interviews. And we're not talking about a Band 4 interview, we're talking about an 8A interview. So it covers all levels. It covers all levels. And if there's any question about this stuff, it's all covered up. Also, I'll give you more info. For instance, say you're done with school, you have an interview and you asked about limb systems. How do you work with limb? You don't even know how it works. With this, you should be, if you come to this area, you could see that a laboratory information system, you could see a real world laboratory information system, how to do booking bloods, how to register requests in the lab. You have all this information there. If also you want to make inquiries about portfolios, so we do have a portfolio, but it's not open-based. Our portfolio gives you the opportunity to also do your individual learning, also to improve your tax. But from our portfolio end, you could see that you should have information about the IBMS registration portfolio, the CCME portfolio, the specialist portfolio, and also the HSD portfolio. So we do have information about that, but due to the knowledge gap in this, would want our AI, biometrical AI, should be able to give you the opportunity to test your knowledge. So there's a learning part here. You need to prove to the AI that you understand how the laboratory works. And once you do that, you should be open to answering most of your portfolio questions. So individually, as different specialties within biomedical science, you could see all these specialties. You have histology, biochemistry. We have more specialty coagulation. So, instance, if we go to coagulation and we want the virtual laboratory in coagulation, you could see that you do have normal routine coagulation, advanced coagulation, DOAC monitoring, hemophilia. So, just to test our AI on this, we could come and test this and say a routine clotting screen samples were sent to the lab. We could run the test over there, and when we run the test, we've gotten our results. You could see the PT result and INR results and the clinical interpretation of that. You could run this for APTT, fibrinogen, and D-dimer, and based on the results you've done, if you want full understanding of the result that was generated, you do have biomedical AI that could analyze those results and give you a full, in-depth understanding as a consultant biomedical science level of what this result entails. With that, you have full understanding of whatever you're doing. So you can see that the result is out. You see this result provides a comprehensive interpretation for a prolonged PTI now drawing from experience, NHS experience and IBMS level competence also. So you could see that it explains everything. It explains everything for you in terms of the pathophysiology, pre-analytical consideration, and the clinical collaboration. It does all that for you also. I know the previous interviewer, the previous correspondent was speaking about questions about biomedical science. So in this section here, it's more like you have 149 articles about biomedical science. It's going to be like, there would be almost all the questions you're trying to ask. Is biomedical science degree worth it? Yes. You have more than enough information, updated information about it. If you're looking about the pharmaceutical industry, you have information about it. So So the idea is that biomed interview prep, it's there to give you all the information you need. And although we do have a paid subscription to have full access to this, but we are also UK registered and we have access to universities also. So for instance now, we do have access to universities also. So our target is to synchronize with various universities within the UK to be able to give students the opportunity to have access to this even within their schooling time. So they have more than enough information to prepare. So we do have a pricing standard for this, but I think it's up to every student. If you want this, and based on the subscription plan is a bit really cheap, but it's more like 90% off for universities to have access to it. So if anyone wants this, I think it's just to pitch to your university if they are happy with this. We have correspondents also speaking to different universities also. But the idea about this is to give a student biomedical scientists and also practicing biomedical scientists the full information they want to pass all their interviews at one sitting, because you have everything involved. Yeah, so that's more of biomed interview prep. If there's any question anyone wants to ask, I'm happy to answer. Does anyone have any question about interviews? Question? Yeah, so I'll wait for yeah, that's fine.
Thanks for your presentation. I just want to ask, is these applications, do we have like a software and an application for this?
Yeah, this is an application. So if you check it, biomed interview prep, it also have a mobile version that can be installed. So you could install it on your phone also. Yeah, but I think it's more preferable based on the graphics and everything to be used on your laptop. Obviously, you're learning. Yeah, but yes, you could. If you see this area here from here, so you could install biomed interview prep and your mobile app, either iOS or Android. You should install it there and have full access to it. Yeah. So this is much of what it is, and we do have a discount. So we're doing a discount now within the bear with me, show you the discount. Right, so we do have a discount for 30% off to get access to this if you use the promo code IBMS 2025. Right, but I think it's very essential that if this is something you want, speak to your university representatives, and because it's really cheap. We are registered with UK Federation, so we do have access whereby you could access biomed interview prep with your uni ID, uni login. So you're not literally coming directly to the website. Once the university registers with us, you could just use a uni login and get access to this, especially for new graduates or anyone within your third year or your second year. Most of these band 4 questions depends, and what this does also, it gives you the flow of not just only sticking with just one specialty. You have options to try other specialties also to see what best for you. Yeah. So for instance, if you want to go for histopathology also, you do have 90 band 6 histopathology questions also that covers 90% of most of the questions being asked within the UK NHS laboratory, and gives you a well-constructed answers for that also. So, does anyone have any other questions, please? No? Okay, that's fine. I'll wait for the other presenters to come in. Thank you. Yeah. Yeah. You can acknowledge whatever, but if you go to
So the question was around doing a placement inside your degree, so between your second and third years of study. But then if you don't, because placements are really competitive, there may be 20, 30 applicants for 3 or 4 positions within that local NHS trust. So what do you do if you're not one of those applicants that gets offered those positions? So it was a case of, if I don't do placement during my study, is there an opportunity to do something like it afterwards? Are there any benefits to doing it between the years of study, benefits to doing it later? So along that line of thinking. So if you're sat there thinking, I really want to be a biomedical scientist, then it's probably quite clear to apply for that placement year, but you may not be that individual that actually gets offered it. Ultimately, if there's so many people applying, it becomes difficult. Doing your best, there are no guarantees, and everybody that's interviewing you appreciates you for what it is you're trying to do. So if you know you want to be a biomedical scientist, go for the placement year. You may not know at this stage, and that is very reasonable. I still don't know what I want to do when I grow up. You know, it's perfectly reasonable to not know what the answers. So it may be for you that you want to go straight through with your degree, complete the 3 years of your study, and you might want to work in research, you might want to work in different areas, go into some kind of entrepreneurship, all sorts of different things out there. Consider and try your hand at, but nothing to say that there isn't going to be something in a few years' time that holds you back and says, you know what, I loved my degrees, I think I might want to go and work in laboratories. What are your options then? Can you still apply? Well, the answer is yes. So long as you completed that accredited degree, and it is the accredited degree that's obviously essential, you have to have your accredited degree. As we know, those modules where we can't adjust your marks, that you have to hit that threshold of a pass mark, so long as you have all those and you have that completed accredited degree, you can apply to complete your registration portfolio in a trainee position later. So you could not do a placement year, complete your 3 years of study on your biomedical science degree, and then answer the job adverts that you can find on NHS Jobs, for example, that are trainee biomedical science roles. Phone up, as the advice was from Manfred about getting in touch with the people who may be interviewing you, or the HR, because you may not be able to get through directly to an interviewer, but getting in touch and saying, this is my position, I have graduated, I have a fully accredited biomedical science degree, I would like to complete my registration portfolio in this training. Is it possible in this application that I can see? And they should be able to tell you straight away, yes, trainee position, you can complete the registration portfolio in here. So there are those different routes. So if you have any questions, the first slides by Vicky first thing this afternoon, they'll be really useful for you. So you've got your placement year between second and third year, but you can apply to complete the registration portfolio in a trainee role after you have graduated. So does that sound fair and reasonable to those of you that know the role more familiar than I do. Yeah, I'm getting nods from the front. So you do have those different options. So I just thought I'd answer that to the room because I think it could be a common question. So, are there any more before we move on to the second round? No? Okay. I'm just going to check what time it is. Okay. So it is 3 o'clock. I'm going to wave at Liv. And please wave it back. Marvellous. So in this section of the afternoon, we have biomedical science specialism lightning talks. So we have 3 talkers. We have Eloise and we have Reece, who are sat at the front. We also have somebody called Lucy, but I haven't met Lucy. So I have a suspicion that Lucy hasn't been able to make it, but yeah, it does appear that way. So actually we're going to have a slightly shorter first section here. Eloise and Reece can still come up and do their talks. So Lee, the first presentation for Lucy, we'll miss that one. Thank you. And we will take a break. Again, do your networking, walk around, talk to everybody, pick their ideas, ask questions, and we will take a break and we will move on to the second part of this, well, the third and final part of this afternoon. So I will bring Eloise, you the first one. Yeah. Yes, you are indeed. Yeah, marvellous. So, as we pointed out, they're there as well for you to have a look at. And we just have forwards and backwards. Okay, lovely. Thank you so much.
Hello, so my name's Eloise. I'm a biomedical scientist in haematology and blood transfusion at Gloucestershire Hospital's NHS Foundation Trust. So just a little bit about me and how I got into the profession. So I've been a biomedical scientist for about 2 years now. I graduated from my IBMS accredited degree at the University of Staffordshire in 2022. As Claire was actually just saying about kind of this route, I didn't actually do a placement year integrated in my degree. So I graduated with my bachelor's degree, and then in 2023 I went on to become a trainee biomedical scientist, where I completed my IBMS registration portfolio, and now I'm HCPC registered and have been for the last 2 years. So what is it that I actually do? So I work across Gloucester Royal Hospital and Cheltenham General Hospital, and I work in both haematology labs and blood transfusion labs. We provide a 24/7 service 365 days a year, so we never close. So I work on a rota to cover all of those shifts. So I work days, nights, evenings, weekends. I'm not selling it, but it's not that bad. And every day for me is completely different. So, as part of my role, I work in the routine haematology lab. So, broadly, we cover full blood counts, morphology, coagulation, hematinics. So that covers, you've probably heard about B12, folate, ferritin deficiencies. We test for those. And then also hemoglobinopathies. So that's looking at things like sickle cell and thalassemia. I'll go into a bit more detail on a few of these. So, arguably, one of our most important screening tests that we undertake in haematology is the full blood count. So we're looking at patients mainly hemoglobin, platelets, and white cell counts and differentials. That's kind of what our clinicians are most interested in a lot of the time. We manually review any full blood count result that kind of falls out of range. And when we do see something that we find a little concerning, we might attempt to look at a blood film. So that's where we can physically look at the morphology of the cells under the microscope, and that can help us determine what might be going on with that patient. And we pass those findings on to their clinical team. So we see a lot of hematological malignancies. So blood cancers, for example, this top film is from a patient with an acute myeloid leukemia. We see a lot of anemias. So this second blood film down here is an example of a patient with an iron deficiency anemia. So as you can see, we've got some quite big white rings in the middle of those red cells, and that's just showing there's not, they've got a really reduced oxygen carrying capacity. So this patient, they present quite tired, quite short breath, quite pale. And then at the bottom there, we've got an example of a patient who's actually got a malaria infection. So specifically, this is a Plasmodium falciparum infection, and you can see the little parasites inside the red cells there. So we're involved in diagnosing all of these sorts of conditions just from a full blood count. We also do coagulation, so this is looking at a patient's the ability of a patient's blood to clot, essentially. So we run clotting screens, so they're looking at any issues that a patient might have in different parts of the clotting pathway. We monitor anticoagulant therapies, so we do INR testing to monitor patients that are on warfarin, and we also undertake anti-10A assays to monitor patients who are on heparin. We run D-dimer tests, so these are tests that can be used to exclude the possibility of a patient having a blood clot. These are really helpful, especially in some of our more urgent settings like ED and same-day emergency care, where doctors can essentially get right, they don't have a blood clot, let's move on, let's identify the next thing, because we can turn these tests around in about an hour. So it's a nice quick screening test for them. And then additionally, we're all trained to run special coagulation tests as well, so things like factor assays, whereby if we've identified a clotting problem when we've done our screening tests, we then drill down and we say, okay, what is that problem? And we report that to our consultants who report that out. So, quick whistle stop of haematology, because I'm conscious of the time and I took far too long to do this when I practiced it, so don't wait until everyone else is doing. So I also work in blood transfusion. So the transfusion lab is split kind of into two main parts. So we've got blood grouping and cross-matching. So when we are blood grouping, first we're identifying a patient's blood group. No, that is, I've gone somewhere else with that one. We're identifying the patient's blood group and also whether they have any blood group antibodies. We also undertake antenatal serology, which I won't touch on too much because I don't have time. But essentially we're monitoring pregnant people, we're trying to identify whether they have any blood group antibodies, and some of these can be more significant in pregnancy than others, and they can carry risks such as hemolytic disease of the fetus and newborn, so it's important that we identify and monitor and quantify these antibodies. And then there's cross-matching, so what we're doing here, we're selecting suitable components for transfusion, so components that are safe for patients, and then there's also a little bit of management of major hemorrhage as well. So, these are just, there are lots of components and batch products that we issue out, and if I went into every single one of them, we'd be here all day. So I've just kind of put up the four main players that I would kind of say that we're issuing out. So we've got our red blood cells, where we're trying to give the patient a nice boost in haemoglobin, they're having packed red blood cells. We've got platelets, FFP, so fresh frozen plasma, and what that contains is clotting factors. We've also got cryoprecipitate, which is a bit like FFP, but it's more concentrated and it's got higher levels of certain clotting factors like factor VIII. So, blood grouping and antibody ID, which is where I was trying to go earlier. So, we carry out an automated blood group and antibody screening on every sample that comes into the laboratory. So this top one up here, that's an example of a group A pos. Sometimes we can't get accurate blood grouping results from our analyzers for various different reasons, and in that case we can repeat the blood groups in tube, and we can often exclude some of those variables when we do that. Every sample will undergo a 3-cell antibody screen. Essentially what we're doing is we're testing the patient's plasma against 3 different reagent red cells, and we have reaction patterns for those reagent red cells that would correspond to certain antibodies, so we can hazard maybe a little guess at what it might be. Any positive antibody screen has to undergo antibody identification. So we run our antibody ID panels here. You can see this lovely confusing looking diagram on the bottom right. We're essentially testing that patient's plasma against a greater number of reagent red cells, and we're comparing the reaction patterns, and we're trying to exclude every possible antibody. So we've basically then isolated blood group antibody that patient might have. So in this example, we've got an anti-Big K. So that moves us quite nicely through to cross-matching, where we're trying to select a suitable unit for that patient. So, for example, our previous patient here, they were A positive, so ideally we'd like to give them the same blood group, so we give them A positive. But it's also important to remember they have a blood group antibody. So they've got an anti-Big K, which is a clinically significant antibody, so this unit needs to be Big K negative. Otherwise they could have what's called a hemolytic transfusion reaction, and they can bleed very poorly. So we don't want that. It's more important to make sure the unit is antibody negative than to make sure, antigen negative, sorry, than to make sure that it exactly matches their blood group, so we can have, a compatible unit, such as for this patient, an O pos, an A neg, so long as it's count neg, but it would be nice for it to be both. Some patients do have special requirements. For example, irradiated components, so you can see this unit of red cells in the middle here. It's got this little sticker on it, and that essentially means that it's irradiated, so it's gone through another process after it's been leukodepleted, which means it's had all white cells removed. Some patients, such as patients that have Hodgkin's disease, will require these irradiated components. Occasionally, it might be that we can't cross-match a patient in-house, and that might be because they have quite a repertoire of antibodies. So some of our regular haematology patients that we see in clinic quite frequently, unfortunately, due to repeated transfusions, do have quite a repertoire of antibodies. So some of these cross-matches we do refer to red cell immunology in here in Birmingham, and they can cross-match the units and send them back for us. Very grateful. So this part of the job always, I think, seems the most scary, and that is managing major hemorrhage. So this can happen any time of the day, any day of the week. It tends to be 5 AM on a night shift is often when the major hemorrhage beep goes off. So managing major hemorrhage really is all about the timely provision of components. And it's working with the clinicians to provide the safest care that we can for that patient who is bleeding. So there are some situations where, yes, the patient's bleeding, but actually they're in theatre, they're undertaking cell salvage. There is actually time for us to cross-match that blood and make sure it's safe for that particular patient. But it's really important to communicate this with clinicians, because sometimes there's not that time, and actually it's safer to give a patient cross-matched emergency blood just to kind of get their volume up than it is to wait. Because, you know, there's no good having perfectly compatible units if the patient's already bled too much, is that? So that's kind of the main thing in managing major hemorrhage. It's all about communication. It literally can be the difference between life and death for a patient. So it's really important. I find for myself, like, when that bleep goes off and when I start handling a hemorrhage, I literally turn into a different person. Like, you are the voice of reason, I think, sometimes for the situation. You really are, right, we've got this, what do you need? I can give you this in this exact amount of time. You have to be really, really clear. So that's a bit about major hemorrhage. And then finally, I'm actually keeping quite a good time. Just a little bit about how my degree prepared me for a role in the clinical laboratory. So obviously, along with your theoretical modules that you'll do, which obviously are very important, they're your underpinning all your scientific knowledge, there's also other themes that run throughout the degree that are really important to take away. So there was a big focus on professional development throughout my degree. We actually did have a whole module on it, I think, in our second year. And obviously that's essential for you as a biomedical scientist as you go through your career, because there is that continual professional development requirement of you throughout your career. So it's important to kind of learn how to reflect and the kind of elements you need to be looking at. So that's very useful. Now also your practical skills, so developing your laboratory skills, learning to adhere to good laboratory practice, which is really important every day, and to be able to follow standard operating procedures in the lab. There was also quite a focus on my degree on recognising not only pathology but also other healthcare professionals as being part of one big multidisciplinary team, all kind of serving the best needs of the patient. So within pathology, we utilise each other's knowledge. For example, when we're in haematology and we're interpreting some of our blood test results, we're actually looking at the results that have come out of other disciplines also. For example, when we're looking at coagulation results and trying to decide, you know, is that normal for that patient or is there something more that we need to do? We'll often turn to their liver function tests that are done in clinical biochemistry, and that will help us inform our next steps. So it's important to see kind of within our own profession that we're all very much working together for that patient, but also outside of our profession. And really this relates a lot to my work in blood transfusion, is actually speaking with other healthcare professionals. So we've obviously got the clinical team, so we've got our doctors, our nurses, when we're kind of going back and forth about transfusion requirements on the phone. A lot of the time we're trying to prevent unnecessary transfusions, so we'll never say no. That's not something we're allowed to do. However, you know, we do kind of have back and forth conversation about what maybe is best for the patient. And that's where our transfusion practitioners are really, really helpful in blood transfusion as well, because they really help to bridge that gap between us and the laboratory and the clinical teams as well, and just to help deliver the safest and best outcomes for the patients. I think that's me. Yeah. So thank you.
Thank you, Eloise. Right, Reece, if you would like to begin. So in terms of seeing the slides that looked out there, and you just have a moment to try.
So, good afternoon everyone. My name is Reece Humphries and I'm a biomedical scientist working in the Cytology department at New Cross Hospital in Wolverhampton. So I was asked here today to just share a bit about my role, the sort of samples and work that I deal with, and how the degree ended up shaping me into the scientist that I am now. So I started my career in the NHS back in 2019 as just a Band 2 medical laboratory assistant. And at that stage, my role was extremely simple. It was limited basically to specimen reception, the receipt of samples, but I wanted more. So over time, I managed to work my way up and earn a place on the biomedical science degree apprenticeship, which allowed me to gain hands-on experience while studying, and it bridged the gap between theory and practice in a powerful way that I hadn't even considered before. And that's a lot similar to sort of the placement years that students will do. So I officially became a registered biomedical scientist last year, and it's still a really proud milestone of mine. Looking back, the journey from MLA to scientist gave me not just technical knowledge, but also a real appreciation of how every role within the lab contributes to the overall goal that we all aim for. So, as I progressed, my role became quite varied. I help lead a team of 15 medical laboratory assistants now in specimen reception and slide preparation. So that involves overseeing their daily work, supporting their training and development, making sure that the department runs smoothly, and leading people who are essentially the foundation of the service. So it's something that I take very seriously, because if the samples don't come in properly, if they're not handled properly, then obviously everything afterwards is essentially pointless. But I think by this point, at least 4 of those members of staff have now joined. They originally joined as MLAs, and they've now completed their registration portfolio and are now working as biomedical scientists alongside me. Another thing that I do is problem solving. Having worked my way up through the department, I built up a lot of practical knowledge about the equipment that we use, the common errors that we see, and I often find myself troubleshooting the issues that come up on a daily basis. This could be anything with instrument faults, workflow bottleneck, or something unexpected with the samples themselves. And whilst I would love to say that my problem-solving process is similar to this one, where, you know, it's all nice and planned out, most of the time it looks like an evidence board where we're crossing out different possibilities by the dozens. Another big part of my role is screening. So, and the microscopy that I do alongside it. So I screen cervical cytology slides to look for cellular abnormalities. It's about recognizing subtle changes that might indicate precancerous conditions. It requires a lot of focus. I mean, we're expected to pick out even one single cell in a sea of potentially 50,000. And it sounds like an impossible task, but me and 18 other screeners manage it on a daily basis. It provides a strong feeling of responsibility, as you'd expect, and as an added bonus, absolutely nothing makes you feel more like a scientist, like a microscope with your name on it. So just a few sort of interesting samples that we get. Well, not interesting samples, because they're all cervical smear samples, but interesting things we see down the microscope. Does anyone want to take a guess at what this is? So that's actually a pinworm, and all of those sort of purple circles that you can see within it are the eggs that obviously it deposits by the dozens, and that somehow ended up on a cervical smear slide. Does anyone want to guess what that is?
Parasite or something?
So yeah, that is a pubic louse. That fell into the sample pot whilst the sample taker was taking the smear sample. Other weird things that we see, we get a lot of different infections, so that's Candida, and whilst, you know, not exactly a pleasant thing to be able to call pretty, a lot of the infections do end up actually looking very sort of picturesque. With Candida, they're very floral. We also get sort of contaminants, so that's a waterborne phytoplankton, which kind of looks like pizza. and other things weird and wonderful. You get groups of cells that will turn into different shapes, such as animals. And a strange cell that I found that it actually formed an R within the vacuole that formed. I think what I really value about my job is the sense of purpose. The work that we do in cytology has a direct impact on millions of women across the West Midlands every single year, and knowing that I'm playing a part in the early detection and prevention of cervical cancer gives me genuine pride in what I do. And as I mentioned, with the problem-solving aspect and leading a team, no 2 days are the same. There's always a new challenge, there's always a new process that could require improvement, or someone else that requires mentoring or assistance. And that variety just keeps me engaged. I was asked, never mind, slide is not come through properly. I was asked how the degree prepared me for working within a clinical laboratory, and I will be completely honest with you, I don't think that any degree can fully prepare you for working in a busy lab. Real learning comes from the job itself, from experience, from the mistakes that you make, from the colleagues who you work with who will share their own understanding and past experiences. But the degree did give me something equally important. It gave me the why. It gave me the theoretical understanding behind the tasks that I'm asked to do. It improved my timekeeping, my efficiency, and the confidence in thinking outside the box when it came to solving problems that we come across. So in short, that it basically gave me the foundations on which to build a career, not just manage my day-to-day job. So to wrap it up, my journey from MLA just 6 years ago to a biomedical scientist today has been both challenging and extremely rewarding. I'm grateful to have a role that combines leadership, technical expertise, and direct impact on patient outcomes, and I'm grateful to those who helped get me there. But most of all, I am proud to be part of a profession that quietly but powerfully makes a difference every single day. So, thank you very much for listening.
Does anybody have any questions for Eloise and Reece? So really valuable insight there about what it is like to work once you've graduated from either an apprenticeship or following your degree. Is there anything you would like to know? Hello?
I'd actually like to ask Reece, so how did you actually get into being an MLA? So what was it that kind of, you know, if you didn't want to go to uni to do that, and then, you know, how did that path start?
So I actually, I wanted to go to uni originally, but I failed my A-levels. I wasn't very good with exams. So I managed to get an apprenticeship in a private lab called the Binding Site. And at the end of that, I had sort of just basic lab experience that allowed me to apply for a great variety of lab-based jobs. And the NHS is, you know, it's something meaningful. So.
Can I ask Reece as well? Oh, sorry, you go first. Sorry.
No,
it's up to you.
Okay, I just wanted to ask Reece, the pictures that you had up of the different contaminants that you'd found in samples, if you come across a sample with something like that, do you have to disregard the whole sample, or can you still run tests on it even though there's a contaminant there?
So we can still run tests on it. Our initial testing is actually a HPV test, molecular-wise, that uses PCR. So even with those contaminants, it still detects whether high-risk HPV is present. The slides, we're looking for any sort of abnormality, as long as those contaminations or infections aren't covering too many of the cellular material. We can still basically confirm whether or not there are any abnormal changes within the cells present on the slide.
And would you have to report the fact that there was something contaminant in it to somebody who took the sample? For example, if it looked like somebody hadn't used gloves or something like that, would you have to report that to someone as like a training need?
So we don't add it in the official report because obviously we don't necessarily want it going back to the patient. That's for the GP to report, do you know what I mean, rather than the letter that we send to them. But we do put it in sort of the clinical notes for the sample taker to be able to acknowledge.
Thank you very much.
Yep, no worries.
So how long did it take to complete the full portfolio?
So I did the portfolio in the summers in between doing the degree apprenticeship. It ultimately depends on what experience you'll have access to within a laboratory. There's so many different sections of the portfolio that some of them can be quite difficult to actually get evidence for. But yeah, so I did it across sort of the 3 years that I was doing my degree apprenticeship.
Thank you. Moving on. Okay, well, because Lucy couldn't join us, it means that unlike earlier, we have a little bit of an earlier break, in which case. So we will take a break now, and we will meet back at 4 o'clock. So please, again, feel free to circulate, come and chat to any of us if there's been anything interesting that you'd like to learn a little bit more of. But then we will have a prompt start at 4 o'clock, and we have 3 talkers. So we have James coming from an industry role. We have Vicky, who sat with us this afternoon as a transfusion practitioner. And then we have 2 people coming from the RAF and the Navy as well to talk about being a biomedical science in the military of defence. So we've got some really interesting talks for the last part of this afternoon. So please feel free to stay with us, to go and stretch your legs, and we will make a prompt start at 4 o'clock. We'll see you again soon. Okay, thank you. And we've had heated debates at the front of the room here. Not entirely sure that it's resolved. But the question is, and I need a show of hands, there's only one correct answer. Can you eat a hot dessert with cold ice cream?
Yes.
Monsters all. That's the wrong answer. A hot pudding goes with custard. Cherry pie was offered here. Cherry pie, I thought, excellent. We're into some really good stuff here. Cherry pie with ice cream. Absolutely no, it's against the law. So just so you are informed, biomedical science, cherry pie does not go with ice cream, it goes with custard. So, we've got...
but on that, hot brownie.
Exactly.
Wouldn't have custard with hot brownie unless it's chocolate custard. No. That's a whole different rolling thing.
Yeah, there's definite geography here as well, isn't there, about permissibles. Yeah, but okay, a hot brownie with ice cream, I can kind of get that. So, and in the final debate of the afternoon, which is winning, lemon drizzle or carrot cake? So we'll have a show for carrot cake. Carrot cake or lemon drizzle? So it's a hands up for carrot cake at the moment. Okay, lemon drizzle. Oh, carrot cake wins. And there were a bunch of people that kept their hand down. Do you not like cake? Do we need an alternative? Hot chocolate fudge cake? Would that have pulled you over? Okay, that got a few more hands. So now we've got the really important stuff sorted out, that we do not eat ice cream with hot cherry pie. And you've got to come back to your final year, we're not letting this go. We have the final 3 presentations for the afternoon, so I'm going to invite James up first of all, and then Vicky will be joining us, and of course then we've got our colleagues from Military Defence coming over as well. So I'll invite James first. Enjoy the rest of the afternoon.
Hello everybody. So is everybody a student here?
Yeah.
Yeah? Do you all know what you want to do after university? Yeah? Some of you not. So I'm just going to talk through careers in industry. So I'm going to focus mainly on my career path and give you a little bit of insights of what I've done, and then at the end go through a couple of careers that I've come across that maybe you've not heard of, or something you might want to give a bit of a Google to. So I graduated university in 2019 with an IBMS accredited degree, not too sure with what I wanted to do afterwards. So I developed a lot of skills, just like you are now, laboratory skills, writing skills, communication skills, and an understanding of lots of different disciplines, and also a lot of those more softer skills, so your determination, your preservation, and your survival getting through your dissertation. But I wasn't too sure at that point what I wanted to do next, and I wasn't really too sure what was out there, whether it was a master's, a lab job, go travelling or to move home or stay where I went to uni. So after a bit I settled that I wanted to work in the lab. That's the bit at uni that I enjoyed the most. But I had a few other things in between while I couldn't get a lab job because they're hard to come by and there's lots of people going to interviews. So I initially started JD Sports, paid the bills. I ended up working at Ferrer and then I was a delivery driver for a bit and eventually I got an NHS lab role. So I started in the labs as a laboratory assistant. That was in microbiology. I enjoyed the plating and things like that. And I gained a lot of new skills working in the lab. And even though that wasn't the career I wanted, and I wanted to go straight to being a biomedical scientist, there was a lot that I developed along the way. Understanding how the labs worked and the quality control, understanding the guidance and things like that. And eventually I got a trainee position down in Wales. So thank you to Public Health Wales for that. So as a trainee biomedical scientist, this was during COVID. So I did a huge amount of COVID testing, the PCR testing, rapid testing. As I was one of the first people in the labs, I helped to set up a lot of new things and it offered me a lot of new skills. And then after graduating, I moved down to a microbiology lab, back to where my skills were, my initial skills. And I started to cultivate bacteria and identify and work in the lab and do my training portfolio. But after a bit, I decided that actually being a biomedical scientist wasn't for me. That's what I'd always thought I needed to do with a biomedical science degree, but there was a lot of options that wasn't that path that we seem to all sort of go towards. And that's when I started applying for commercial roles. So my first commercial role has been with Hologic as a commercial solutions specialist. So this provides a lot of application support to the labs that use the systems that my company sells. So the Panther systems are what I currently train on. So I provide a lot of training to those labs. We help them through the verification of new products, and we help them with new assays. I also support with the cervical health labs, so a lot of the cervical health changes, with guidance, with policies, making sure the equipment still fits within that, and also provide the troubleshooting to the labs, to the lab staff, lab managers. But that was my day-to-day within my role, but there's a lot of other things that I cover. So there's a lot of travelling with commercial roles. So I travel around the UK. I mostly cover the southwest of Wales, but I do occasionally travel around to Ireland, Scotland, London, lots of different places, lots of travel. You'll either love it or you'll hate it, and that's definitely something that will guide you whether you want to go into an industry career. I do a lot of workflow analysis, so guiding lab managers through how they can improve their workflows, making it more lean to provide savings, things like that. I assist with the writing of tenders, so when the NHS is looking for new equipment, I respond to those. I also support with the KPIs, so they're the key performance indicators. So once equipment's installed, I make sure that they are running at a good level, 99, 98%. And also building pandemic preparations with the lab. Obviously we have COVID, the labs are still gearing up for whatever might be next, so making sure that my company can support with whatever does come next. So there was a lot of skills that I've gained along the way, which allowed me to get into this career. So some of those have come from university, like degree, a lot of writing skills. Other things have come from my other roles, customer support skills, which are invaluable to every day and in most jobs. Again, with teamwork, microbiology experience from working in the lab, and understanding laboratory policies and guidance. And then also from my portfolio, obviously gaining my training portfolio, which has been valuable throughout my whole career. And then other things like the quality control and laboratory testing methods. But these are some of the roles that I've come across. So starting where I started, which was biomedical scientist, but there's also roles like technical solutions specialist, So this is providing over the phone or email support, more office-based roles, working for companies to support the NHS and private labs. Quality assurance analysts, so testing various products before they go onto market. And a research and development scientist, developing things, testing how things work before they go onto market. You can work your way up in the lab or towards lab managers and work more the office side of the lab. There's lots of roles like forensic scientists, or you can go on to do masters and things like that in that area. Application support, so providing the training for labs, providing the on-site support for instruments and things used within laboratories. Account management, so that's more of the business side of things. So with the account management, you will be managing books, assuring that targets are hit, finding new business, securing new business, and then commercial solutions specialist. So that's my role, which is a bit of a hybrid between the account management and the application specialist. So there's some photos of me and some of the things that we do. Obviously working at trades, things like that. Training within the lab, and then also volunteering work that I do on the side. And that's really it. So, I mean, have you got any questions on careers in industry, how I find it compared to the lab, anything like that? Is everyone too scared to speak? Well, my LinkedIn's there. I'm more than welcome, more than happy to respond over there if you don't want to speak out. But yeah, there's loads of different things. I've recently just moved jobs, so that's not my current role. I'm moving to BD as a full account manager. I found a lot of my job searches have gone through LinkedIn. Having a good LinkedIn profile I've found has really helped me within industry. Probably not the same for everybody, but definitely a really useful free tool that you can all use as you graduate. So yeah, that's me done. Thank you for listening.
So we will do exactly as we have done earlier through the afternoon. If there are any questions, come and see us whenever you would like to after the end of the presentations. But I will invite Vicky up next.
Thank you very much. So good afternoon, I said good morning then, definitely not morning, is it? So I'm Vicky, I'm a transfusion practitioner based up in Rotherham. If no one knows what Rotherham is, it's near Sheffield because that's the next closest big city. What I'm going to talk to you today about is a transfusion practitioner, because the best thing is no one knows what biomedical scientist is. Add this into the mix and you've got no hope. But how a transfusion practitioner facilitates a really important part of the integral patient care pathway, which I'm going to guess is the majority of the reason most of us get up for work in the morning. So just a little bit of background, so I haven't put on any of my slides about me. I feel incredibly old after talking to you guys today, but I graduated in 2014. I started my placement journey back in 2012, so yes, that is over 10 years ago, which makes me very sad. It feels like yesterday, but it was the most incredible experience, and I love being a biomedical scientist. I identify as a biomedical scientist because that's who we are, and not all heroes wear capes, as you'll find out from my presentation. So the skill set. These are skills that you are developing now, okay? These are skills that you will develop through your education career. They will develop from your work experiences, and they will be naturally progressive. You can see that some of them are slightly bigger than others because you'll naturally be more inept at some than others. So IT skills might be your kind of forte, whereas for me, I have to work pretty hard at it. But these are things that you will start developing and have developed through university, through apprenticeships, whatever it might be. We'll come back to that slide a little bit later on. But taking it back to where it began, where did transfusion practitioners begin, if you like? So they've been around as long as transfusion's been around in essence, because what our role is it's a really core part of transfusion care pathways, okay? But the need for it and the role itself, the terminology that we're going to start talking about, actually developed from the early 1990s, which is when shocks or serious hazards of transfusion was kind of developed and came into being. They're a haemovigilance body. They're integral in making sure that transfusion is as safe as it can be. But whether it's from shot or whether it was endorsed by a lot of other bodies, including SABTO, NICE, I should caveat out, transfusion, as most of sciences, love an acronym. We love to talk in a different language. Please stop me if you have a question about what I'm talking about, because it doesn't make sense. I'm more than happy to do that. And over the last 20 years, this role has expanded and developed, and bits have been bolted on and added to, and it's becoming a lot more recognised, and people are understanding how that role sits within healthcare. Now, I talk about transfusion practitioner as an umbrella term. As you go around in organisations and you kind of progress through your careers, you will also potentially hear them as called SPOTs, which are specialist practitioners of transfusion, haemovigilance nurses, transfusion officers, or the TP person thing. Different people call it different things, but it is an internationally recognised role. We, as a country, so in the UK, we are quite ahead of the curve in that. But like I said, across the world, this role exists, and the role exists because we care about our patients. So what do we really do, apart from most people think sitting in the office making up extra rules? I promise we don't do that. What we do is we act as a bridge. So like I mentioned, I'm a biomedical scientist in haematology and transfusion by background. Came into this role because we act as a transfusion practitioner as a bridge, if you like, okay, between the clinical area and the technical area, so you guys in the laboratories. But as well as that, we all act as a bridge within the organisation, both where we work, regionally, nationally. You're liaising between what the organisation needs and what they've got funding for, and making sure that all the MHRA guidelines and the SABTO guidelines, and I can ream off a whole host of them for you, but is your trust meeting them? Is the trust safe to deliver a good, high-quality transfusion service? That's what they're looking for your TP to make sure that they can go, yes, we've done that, don't you worry. Eloise made a really good point about massive hemorrhage earlier on. When the chips are down and you've got that patient bleeding out, your TP can often step in, and they'll be that acting there saying, okay, clinical area, you need that, lab, you need this. How are we going to get to point? Okay, where are we going to get to with our patient? Because in transfusion, as many other disciplines, the bag that the BMS handles in the laboratory, right from NHSFT all the way through, is the same bag that that patient will save. That same bag of blood that will save that patient's life, okay? It's one of the very few disciplines, I sound like I'm pitching it, I don't know, but it is one of the few disciplines that you will actually have a direct link to a patient with, okay? And it's not going the other way, it's not just a sample in a bottle coming to the laboratory, you've given that to the patient. So in transfusion, we are all on the same team. We are just doing slightly different roles in that. So the best analogy I can give of being a TP is you are wearing many different hats. And I say no 2 days are the same. No 2 hours are the same some days. So you can be at one point wearing a top hat, and the next minute you are running down the corridor putting your fireman's helmet on going, hey, what's going to face me now? Which is what makes it so exciting. But it's also what you do already in the laboratory. A lot of the skills, which I'll come to in a second, you start adapting, fulfill this role here, okay? Because as a TP, we are training officers, we are delivering training to clinical and laboratory staff, you are a haemovigilance officer, making sure that you've written any SOPs, pulses. It's all written there, you don't need me to waffle on about it, but it's understanding that how does transfusion relate to that safe patient care? Because while you all get up in the morning to work in the laboratory, to help the patients, whatever discipline you're in. Same for a transfusion practitioner. It's the same for a doctor. We all just have slightly different roles to play because we can't all do it all. Now I mentioned about this skill set. So as a TP, you've started out and you've kind of got those core-based skills. This is what I've developed in my role. I've been a TP for 5 years. This is what you will all develop. Some of these skills will be developed organically, by your experiences, by your exposure to situations, by your education, by your friends, colleagues, whatever it might be. But there are other ones as well, like, so I mentioned about linguists. I said that I like to talk in acronyms, as does many disciplines. That's because as scientists, but as clinical staff, we all speak our own language. But communication is, can we speak the same language? And if we can't, how do we get our same message over? Because again, going back to Eloise's talk earlier on, communication is key, clarity is key. You don't have time to say, did you mean X or Y? It's this is X and this is Y. Now, I would not profess for a second after feeling pretty old today, as to I'm not old, but wouldn't say I'm an influencer. In a world of TikTok, in a world of social media, and you know, everyone wants to be the next YouTube go-to guru. Actually, you're an influencer. As a scientist, as a transfusion practitioner, you are an influencer. You influence that patient's care every single day. But that skill set is something you will develop. And like I said, again, these are in different sizes because as your career progresses, skills change, they ebb and flow, and what you need in that role. You know, we've just seen one about kind of, I was going to call it corporate then, it's nice commercial kind of industry roles. Skill sets, correct me if I'm wrong, but are the same. Yeah. You are still developing really core transferable skills that mean something. Hey, so I thought that was going to work, then I panicked. So, a little bit of background. These are just a snapshot of papers and evidence of why the transfusion practitioner role is key, okay? No, you'll at least know I'm not going to go into each one in detail. The one I would just draw your attention to is you may or may not be aware of the infected blood inquiry. It had some media coverage, it was released last year. It refers to the scandal, as it was denoted, for the affected patients between the 1970s up to the early 1990s, where infected blood components and products were issued, okay? Transfusion safety has increased phenomenally since then. It's almost a different landscape. But transfusion scientists, doctors, clinicians, practitioners, we're all in this together. We are going to enact the recommendations that were set by this report to make sure that our patients get the next best care moving over the next 5, 10, 15, 100 years' time. We don't know where it's heading. And I wouldn't be a transfusion practitioner worth my salt if I didn't mention the 3 pillars of transfusion, okay? But while as a transfusion practitioner I'm going to endorse these apply to everyone, okay? Whether it's you guys in the laboratory or whether it's the clinical teams that are enacting it, what we're trying to do, this is get the best patient care through transfusion, okay? And how we do that and where we're headed. So what's the future? I'm talking to the future right now. We don't know. We started with samples attached to glass bottles. This is transfusion 101, if you like, okay? We've now moved, we're here currently-ish, give or take. We're in a very risk-averse, very safe transfusion. We are a very lucky country to have the transfusion service we have. But where's it going to head? We might have synthetic blood. Who knows? What's going to happen with our research? The doors that are going to open are endless, but it will take a whole village to make this happen. And like I said earlier on, that not all superheroes wear cape. The skill set that you are creating and developing for yourselves, let's say transfusion practitioner is just one of the opportunities that you can have as a biomedical scientist in your career path. Because the transfusion landscape never stays still. It's ever developing for patient safety, and that's why the doors are opening. So you guys are going to be that future, and where you're going to drive it, you're going to be the transfusion practitioners of tomorrow. Oh, sounds really nice, doesn't it? So to the next generation, thank you for listening. If you do have any questions or queries, or want to know anything about transfusion, I'm going to say that. I might not be able to answer you, but I'll point you in the right direction. Please come talk to me. My email's there if you don't want to kind of shout out. Might have some silence. Thank you to the IBMS and Student Congress for inviting us here to have that conversation today. It's a great opportunity to talk to you guys. And I say Jen Rock and Jill Caulfield also for kind of having some input on this. But like I said, we're all one team. So there we go. Any questions right now? Unless you want to save them to the end and I'm going to dive off.
Any quick, because I know that some people actually have to set off for trains, so just to kind of, I know we're taking questions at the end, but if anybody does need to dive off, do you have questions for Vicky? No, not for the moment? Okay, well, super, thank you. Which leaves our last talk for the day, which is Olivia and Lucy, who are just sat at the back there, hiding away.
Yep, hiding. We found you.
So we have Olivia and Lucy from the Royal Navy and from the RAF to talk to us to finish off the afternoon, so I shall leave you. So the only things that you need is literally this thing. So that's not on a laptop, we don't need to use that. The screen is there and it's just It's picking up from this microphone, so I will stand here, but you can still do it waving and watch it.
Okay, good afternoon everybody. Thank you for being here after what's probably been a very long day of lots of presentations. So we won't make it boring, hopefully make it a little bit interactive and hope you're still awake. Yeah, please stay awake. So anyway, I'm Lucy, this is Olivia. We work in the military together and we're going to talk to you about a very niche kind of career path within biomedical science and a career path that not many people know about. So yeah, we're just here to share that today. What we're going to cover is the training and education part of it, so the fact you can get a degree through the military or come in if you're already pre-qualified, the clinical placements that we do, what departments we cover. We're then going to look at the personal development that's offered within the military and what the military can offer you back. And then the big thing, deployments and operations, so what we offer kind of overseas and what it looks like.
So this is just an overview of like the whole training timeline, and we're going to break it down and just kind of go through each bit. So you've got your basic training. This is done like regardless of what prior training you've got, what education you've got. Everybody goes, everybody does this basic training. You've got the army down at Harebright in Surrey. That's 14 weeks long. You're doing a lot of field craft, drill, learning how to iron your uniform, all the basic military requirements. And then for myself, it was the RAF. So this was 10 weeks down at Aylesbury, RAF Halton. And it's a similar kind of thing to the army, but just a little bit less time in the field as it's not as relevant to us really. But yeah, I really enjoyed it. There's some great elements to it. You're doing all the rigid like inspections and the marching, learning how to do your weapons handling as well. But you also get like adventure training, you get to go and do different things, so it is really good.
The Navy's pretty much the same, so we do 10 weeks, but we don't really touch the green stuff. We're not really au fait with getting our hands dirty in the mud, so normally most of our stuff is done either on ships or we're on boats, as you'd expect. We touch more on kind of the firefighting. We still do a little bit of the weapons handling, but if you see me with a rifle, please run the other way because I am no good with a rifle.
I got you.
So these are some pictures from basic training. Although I look very happy to be in muddy water on that top left, I was not. The smile is definitely fake. But yeah, that's just a glimpse of kind of what we do, the kind of the green side of like obstacle courses, and kind of the camaraderie that comes with basic training. And then the two kind of on the right of the green stuff is the pass out, which is the best bit. It's the way you can leave the 10 weeks of rally behind you and you can just forget about it and relax. But yeah, it's a really good achievement and it feels great once you finish it.
Yeah, so I've got my pictures just on the right here. That was, so like the top left of my side, it's like an example bed space. So the instructors and things would set out that bed space and essentially in your area you would have to replicate that and like iron your bed and all this stuff. But after that 10 weeks you don't have to iron your bed again. And then obviously that's a photo from my pass out parade and yeah, it's just like such an amazing day. You know, your family's there and yeah, you can't really describe it, it's really, really good. So next we've got our university. So myself and Lucy, we both joined pretty much straight from school. Our A-levels was the year that COVID hit, so we never actually ended up sitting those exams. A bit of a delay in recruitment because I think we were all working how to live in a pandemic. Eventually joined, did the basic, we went to Aston University, all funded through the military, and then a pretty regular university experience, I would say. You'd think like being in the military, is it really different? It's just pretty much the same, isn't it?
Very much.
In my first year I played netball for Aston and then I did like some cross country with an outside team, lots of coffee, drinking obviously to get through uni, and that was our graduation day, myself, Lucy, and one of our friends and some of our like managers and things.
Again, a really nice achievement after 3 years, and it isn't really dissimilar to a normal uni experience. You can still get involved with the societies, make friends. But yeah, obviously you're kind of channeled into Aston, and that's the only place that the military offers an IBMS accredited degree. So next is our clinical placements. So in the military, we are multidiscipline, so we cover all the departments. So we have training in each one, so that covers obviously biochemistry, blood transfusion, haematology, and then microbiology. Personally, I love being multidiscipline because it means you can just kind of get a flavour of everything. And if you really don't like one department, then you just know in a couple of months you'll be rotated to a better one. So personally, I love the fact we're multidiscipline and what we offer. But we primarily work within NHS labs. So we've got hospitals, so joint hospital groups at Birmingham, Frimley and down south in Portsmouth. And that's where we kind of all work out of regardless of service.
So after you've done all of your clinical placements and things, so we have people joining at various different levels. So obviously we did our university and we did our placement in between each year of university, and then we became HCPC registered. Then we have some people that join and just do a solid year of placement just to get their registration after their degree. Once everyone's kind of registered, we have a 4-month course called Transition to Military Practice. And this consolidates what you've learned in your degree, in your placements, and it applies it to a more military setting. And obviously we'll move on to that in a bit and like what exactly that means. It's just getting used to our kit and equipment compared to what's used in the NHS, our protocols, and it's just learning all of that for 4 months really.
So the fun part of being in the military is that it's not all work, 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 which again, I love, is the personal development side of it. So you can go and do opportunities like sport. It's fully funded, so you can sometimes get kind of a week, a couple of days off work to go and play the sport. So if you're a sportive, adventurous person, then our lifestyle will definitely benefit you. We also have opportunities to do adventurous training, so if you like skiing, snowboarding, any of the above, you can sometimes get a couple of weeks off work, paid for again to go skiing. So there's some really good opportunities on top of military life, or like on top of the day-to-day in the lab, that not necessarily your NHS counterparts will get the opportunity to do.
I think as well with that, you don't have to be super sporty. I think a lot of people think, I need to be super, super fit in the military. Like, there is a minimum standard and it is okay to just meet that minimum standard. Obviously we always want to strive for more, but there's a lot of kind of just, you know, give it a try culture, I think. So that's me diving on the top right. I had never done that before in my life. And one of my colleagues was like, hey Liv, like, come and try this. So I went along for a taster session and I was alright, it wasn't terrible. So I've done quite a few weeks over like the past couple of years, just going and getting better at that, which is quite, just mixes it all up a bit, doing something different. I think sometimes you feel more refreshed going back to your job, having gone and done something like that.
So keeping on the personal development theme, it's not just sports that they offer, it's kind of coaching, mentoring, so really good transferable skills that if you don't see your life being stowed away to the military, you can leave early, and then all of the coaching and the mentoring courses that they put you through will still apply in civilian life, in the NHS labs, private labs, wherever you work. You also go on leadership and promotion courses, so we're very lucky in our trade that we're a very small cadre, and it means that we promote quite easily as such, depending on yourself as a person. But you can go on leadership courses and they teach you again invaluable skills that will transfer if you leave the military, and are recognised by NHS labs, other jobs.
So we do get the fun side again. I feel that we're hopping on about the fun.
It's the best part.
But we do quite a lot of team building days. I think also this is a good opportunity to kind of build your planning skills, your leadership skills, is taking on a role of saying, hey, I'm going to plan this, and all like the logistics involved in that as well. And obviously it's just a bit of fun, get everyone together, building that team. We've done, this was like some paintballing? Laser. We got this together actually doing paintballing. So we did laser tag, we got some go-karting, and then we did some kayaking as well. So some of this was self-funded, but it's still a good opportunity to get out for the day.
It just also reinforces the values, as we are a small cadre. These are the people that when we go on deployments we'll be working with. So these team days really give us an opportunity to get people out of the lab and see the personalities actually come out rather than everyone in their professional setting. So they are really beneficial. onto the part that most people may say is the worst part about the military, is the deployments and being away. So our deployment opportunities are often tri-service, so you're not kind of channeled in. There will be kind of preferences for people to go on deployments. However, as we are tri-service, the majority of people can go on any deployment that is offered. We offer a variety of different things. Our kind of primary capability is blood transfusion and trauma injuries, but we do still offer microbiology, haematology and biochemistry depending on the lab setting and the equipment that we have.
Sorry, what does tri-service mean? That's not a phrase I've come across.
So tri-service is RAF, Army and Navy, so it's non-discriminative when we go for deployments.
So it could be like a Navy deployment, but you could actually find you're working with Army people on a ship and you're like, what are you doing on a ship? Like, you know, but that's kind of the nature of our job, is there's not many of us, so we pull whatever resources we've got really. So here we've got is like what you'd expect of your typical NHS laboratory, very automated, lots of big analysers. Obviously it might vary from place to place, but typically this is what you kind of see. And then, so to kind of counteract that with what we do when we actually work. So this is some images from a recent RAF deployment this year. In the middle, this photo, you've got obviously all the kit is packed. So a massive part of going away, you're not just the scientist doing the science at your bench, you've got to think about the logistics. Where are you getting your kit, how are you getting it, and literally packing it as well, like that is your job too. So the far right picture, that's a very small lab setup. So initially you'll have kit that goes out the door straight away when it's required. And you can see you've literally got a centrifuge, you've got a small biochemistry ISAT analyzer, and you've got a HemoQ to do a hemoglobin measurement. So it's very small, very basic, but sometimes that is all you can provide on short notice. And then obviously there's some other photos you can see that the lab got much bigger as more kit was able to get out, you're able to get your blood, and we're able to provide that full blood transfusion service. So yeah, that's just some recent pictures. So the last one was obviously in like what we call a building of opportunity, but if you haven't got a building available to use, then this is typically what you would see. And these tents are an absolute nightmare to set up. But down the middle of these tents, you can see you've got like a main corridor, and then off each of these tents is like a separate department. So you'd have your like ED, emergency department bays at the bottom, and then you'd have like a theatre where the casualties coming in and they're just like going crazy, like what can we fix right on the spot. And then each of these other tents, you've got x-rays, radiographers. We'd have a tent where we'd have like a little lab, and then we'd also have ward bays to kind of keep the patients there before they can be evacuated. So yeah, it's a very mobile kind of, they don't all look like this. It can vary quite a lot, but that's an overview of what you might see in a bigger scale. So scaling it down a lot more, this is a very basic capability. You've literally got the entrance at the bottom, you've got your emergency department is the first one on the left, you've got your theatres then directly behind them, and then on the right you've got your x-rays and your radiographer. So you've got all these people working together in this tent, and it's all just going on, basically.
Very close proximity.
Yeah. So this is like within that kind of tent area you saw on the last slide, you'd also have your lab. So you're there in the thick of it. You've got your centrifuges and incubators for your transfusion, and then there's a small like full blood count analyzer as well. And this setup would typically be for like just one BMS, just you. You're doing that, you've got to manage your workload, the people as well, it's a huge part of it. And I think sometimes if you can make friends, not friends, but get along well with like other departments. So I know the x-rays and the radiographers, they have like big equipment in big boxes. So like make friends with them and then you can use the box as a table. Like it's great. And this is another one, kind of the same capability, but a little bit smaller. These boxes, these big ones, that's what you store your blood in. You'd have one perhaps at like a frozen temperature for anything that needs to be frozen. And you'd have one cold for your blood, for your reagents and things. So, you know, you've got to make sure they're all temperature matched, quality. You've just got to be all over that quality, and it will get sent back to the UK. Like, they will be on you asking, like, have you done your quality? So we don't just forget about all of that.
The same principles and policies apply overseas as it does in the UK. So any paperwork that we do abroad, we have to send it back to make sure that we're still quality assuring all the blood, all the reagents, make sure everything's matched.
Any questions? I feel like that was a really speedy overview. But, yeah.
We won't bite, I promise. And no question is a stupid question. I know it's a bit new.
Any questions for Lucy and Olivia?
Or does everybody want to go home?
So, obviously we've still got Vicky, James and Olivia and Lucy. Is there anything that you would like to ask those directly about their presentations, any of the content there that's brought questions to mind? Well, lovely. Thank you very much, Rob. That was really great. Thank you. And before we go, are there any questions in general? Anything that you've heard today that you'd like to know a little bit more of? Anything that wasn't quite cleared up that you'd like to understand a bit better? That looks like no. I think everybody's considering train times. Well, thank you very much, everybody. Lots of people have already had to leave, depending on transport, etc. So thank you all very much for travelling down today. I hope you learned lots of information and useful things that will help you over these next few years. So good luck with the rest of your degree, with your placements, the careers that you choose to go on, and whatever adventures you decide. You've got some contact details, so you can come through to the IBMS. If you do have any questions, we can forward them on for you and get some answers. And then, of course, a massive thank you to everybody that's done the presentations today. I think there's been a really interesting mix of different elements of what it is to be in this direction of a medical sector. So thank you everybody that's travelled down. Vicky, you've literally sat here the whole day, so you've got a real nice perspective of the things that we've done too. So thank you everybody, and to the IBMS of course for arranging these types of opportunities. So not everybody does these, so it's really quite special that we get this. So have a great journey home, and please get in touch with us if there's anything you need to know. So thank you all.